Hello everyone, welcome back to Programming in Python Learning Series, and this is session 11. In past sessions, up to 10 sessions, we have seen the introduction, flow of control, functions, strings, lists, tuples, dictionaries, exception handling, and file handling. In this session, we will look at the stack. What is stack, where it has been used, and how to implement a stack in Python, and the rest of topics in the upcoming sessions. Before getting into stack, let's look at data structures. What are data structures? Different data types are available in Python to store data. This grouping is called data structure. Examples are strings, lists, tuples, etc. Data structures define a means to store, organize, access, and perform operations on the data. Data structures organize data elements in a way that certain operations can be done at element level and also as a collective data unit at the higher level. It's just basically grouping elements, data elements in a particular type and providing a means to store, organize, and access and perform operations on the particular data at individual element level and as a whole, the data structure as a whole. Stack and queue are two popular data structures. These are available in general in different programming languages, but in Python, these are not available directly. Meaning, there is no structure called stack, there is no structure called queue readily available in Python, but they can be implemented by use of different uh, data types and certain functions that we can create. So we'll look at how to do them in the upcoming slides. So what is stack? Stack is an arrangement of data elements in a linear order. This is a keyword, linear order, meaning data elements are arranged one after other. They go one after other, meaning they are added to the stack one after other, and they are extracted or removed from the stack one after other. The data elements are arranged in a linear order. Addition of elements or removal of elements happen from a particular end, that is called top of the stack. Just imagine, right? You have a deck or you have a stack of books. If you want to add to the stack or if you want to add to the pile, we cannot insert or we cannot take the new book to the bottom, right? We have to put it on top. And if you want to take out a book, say whatever was placed last or somewhere in between, we have to take books one at a time from the top. So adding elements or removal of elements in a stack happen from a particular end, and that end is called top of the stack. Due to linearity property, the stack follows last in, first out model. As I mentioned in the example bookshelf or bookstore, book pile example, whatever goes in last, whatever was placed last, should be the one coming out first so that the other elements are accessed. The last entered element will be the first to be taken out from the stack while extracting. Another analogy will be a deck of boxes in a warehouse. Huge boxes that are supposed to be moved out are coming in, arranged in a particular readable order or a particular number order. They are stacked one over other, and for most part, they are used or they are being stacked or taken out using forklifts. Human involvement will be limited, except for driving the truck and using the forklift. So if you want to insert a box, a new box, in the middle of the stack or deck, what should we do? We cannot just like that press it in, right? We have to take out all the boxes that are on top of the particular position we want to insert in the new one into. We have to take out everything one by one. When we take out, we have to go pick the one that is topmost, and then the next come down, keep coming down, and then once we reach the position where we want to insert the new box, we place it. And if the arrangement requires, we have to put the boxes on top of it over and over, right? So if I have to place something in between, I have to take out everything from the top, place the new one and put it back. Or if I have to extract anything that is already available in the middle of it, I have to take them out and then reach out the box I intend to take out. So you get the idea of stack, right? It's one way in, one way out, same end. So whatever goes last should come out first. Other examples of stack in real life: pile of clothes in a storage. Of course, clothes are easy to just pull out if you want one, but if you want to insert, bare minimum you have to lift the ones that are on top and then bring the new one in. Multiple chairs in a single pile. You might have seen piles of plastic chairs in party halls or party meetings and so on, right? So if I want to bring something out from the middle, I have to pull out whatever was stacked on top, or if I want to add one, it goes to the top first, or if I want to add in the middle, I have to take out all the other ones on top first and then put it in. So you understand how a stack works, at least operate upon, right? In the computer world, do and redo operations, undo and redo operations. Sorry. So you, for example, take a Word document or Excel document. You type something, and you keep typing, and you want to undo certain activity. When you do the undo operation, either using the arrow or Control C, the last update was undone, and then if you press the arrow mark again, the previous action, and so on. Again, if you want to redo, whatever was done or whatever was undone first will be redone first. It goes back in that order, right? So undo redo operations are a perfect example of stack. Similarly, in a browser, back or forward. So the nearmost will be operated upon first. Stack operations. What all we can do within a stack? Push. Push operation adds new elements to the stack on the top. Elements can be added until the stack is full. If there is a limit set for the stack, elements can be added until that particular limit. Trying to add elements to a full stack results in overflow exception. Naturally, right? You have a limit of how many elements can go into a stack, and you want to add that n plus 1. It's going to throw an exception, overflow. Next operation is pop. Pop is a delete operation that removes elements from the stack at the top. We saw that elements getting added and getting deleted. Push takes care of adding. Pop takes care of deleting the element or elements one at a time from the top of the stack. Elements can be deleted until the stack is empty. Trying to delete elements from an empty stack results in underflow exception. Obviously, right? If we are trying to delete something that is not present, it's going to show an exception. In this case, it's an underflow exception. Now, how do we implement stack in Python? We mentioned that stack and queue are not available in Python by default, as Python does not provide them as standard structures, and we can implement with some operations and functions. How do we do that? An easy way to implement stack in Python is to use the data type list. List handles elements which are arranged in a linear format one after other. So it's kind of an ideal candidate for implementing stack. A side of a list can be fixed as the top of the stack, either beginning or start position or index 0 of the list, or the last element of the list. One end can be set as a top of the stack. And the built-in methods append and pop are used to implement stack. Append, yeah, it adds elements. Pop, it takes out element, pops out element from a data structure. So these two can be used to implement stack. These two methods insert or delete elements at the rightmost end of the list, respectively. Hence, an implicit top definition is not required. Stack in Python, a sample implementation program. How do we actually do it? Let's look at a program. Objectives of the program. So write a program to create a stack in which we will insert or delete elements. Check if the stack is empty, meaning there is no element left in the stack. Find the number of elements in the stack. Read and print the value of topmost element in the stack. Let's go to the ideally, look at the program, execute the program and see what the results are. Let's look at the sample program first. So here I'm trying to create a stack of books. So as we said, list is the data structure we are going to use. So I'm assigning an empty stack with a blank list being assigned to it. And I'm defining a function to check if the stack is empty as a function name. If the length of the stack name book stock is 0, then return true as empty, else return false. And stack size, I want to check the stack size whenever required. So size of book stack, basically the length of book stack. See the previous function also I'm checking for the length of book stack as the stack name. If it is 0 meaning empty, return empty. Otherwise, in this case I'm returning the size. If it is empty and if I'm running the size function, it's going to return 0. As simple as that. Read the most recent element, what is there in the top of the stack. Like define top as the function name of my stack. I'm running the isEmpty function. If it is returning true, I'm going to say stack is empty, return nothing. Else find the length of stack, and through the length of the stack find the book stack of x minus 1, index the late index minus 1, that is top of the stack, the last one, and return that element. So read through the length of the list, find the last one. Remember the index starts with 0 for list. So x minus 1 is the length minus 1, that's the last character or last element in the particular list. Now display the stack content, right? So for length of the books, x is equal to length of the book stack. So from 1 to length of the book stack, increment by 1, print the elements. So basically print all the elements in the list as a stack. Now pop function, removing elements from the stack. I'm defining a function pop from the stack. Check if the stack is empty or not. If it is empty, throw an underflow exception. Else pop. Pop actually takes out one element at a time. Now add the elements to the stack. The first element, I'm giving a book name Wings of Fire, and print a message pushing the element name, and call the push function. Push book stack element. Add the element into this stack. And the next element is go to be notice, some book name, and do the same thing. Push that element into the book stack. Now display the number of elements in the stack. Current number of elements in the stack is call the size or length. I mean size internally is calling the length, right? So size of book stack. So it's going to print how many elements are there in the stack right now, right, so far. And now delete element from the stack. Remember, it's a pop function that is there in the OP pop, and it's going to remove an element at the top of the stack. So whatever was entered last should be deleted from the stack. Now I'm adding one more element to the stack. For every step of the way, I'm printing either the count or the element itself. So on, right? So I'm adding another book. Go to syscreate, call the push function to add that element into the stack. Now what we have done is we added two elements to the stack, removed one at the top, and added another one that will go and sit on the top. Now display the last element added to the stack. So the message is top element is whatever was added or whatever was in the top of the book stack, and print all the elements of the stack. Now I'm going to delete all the elements that are added to the stack and bring the stack to be empty. Let's run the program and see the results. Here's the result. Initially, I pushed two elements in the stack wings of fire and got to be noticed. And I had a message showing the current number of elements, showing up two. And there was one pop. So popped element is good to be noticed. And added one more element to the stack, which goes and sits on top of the stack. Pushing element good is great. The current top element is good versus great that was entered last. Now, since I printed all the elements of the stack after this particular operation, the messages current elements in the stack are good versus great and wings of fire. Good versus great was the last one to be added. Now, I had a condition that if or while true, remove all the elements or pop all the elements from the stack. So each, as long as there is an element present in the stack, keep popping up. So the first popped element is what was sitting on the top and what was there below it. And once it reached an empty state, when there was a try, it gave out an underflow exception, and the message stack is empty now. Some notations for arithmetic expressions and how stack can help dealing with these arithmetic expressions. Any arithmetic expression can be represented in any of the three notations: prefix, infix, and postfix. Let's see what they are. So, expression, when we have a table that describes what they are, first column is type of expressions, the description of that particular expression, and some examples. Infix. Infix is basically what we see in our everyday mathematic resolutions, right? Expressions and resolving them. The operator is placed between operands. So you want an addition, the plus is placed between those two operands, multiplication, division, and whatever. I mean, it goes with the BOD mass rule. You know, the braces, order or powers, division, multiplication, addition, and subtraction. That's a short form BOD mass. So your infix is evaluated, then infix expressions are evaluated with that particular rule. Next is the prefix, where the operators are placed before the operands. It's also called Polish type of expression. So if you look at the examples, the first one plus z star xy. So here the operator plus is for z and x multiplied by y. So in your infix, it will look like z plus within process probably x star y, x into y. So here the operand is placed before the operators are placed before the operands, and a single sweep of left to right will be good enough to understand what the expression is. In the case of infix, that's not the case. You'll be kind of shuffling back and forth following the BODMAS rule. Similarly, in the postfix, your operators are placed after the operands. Uh, so the same expression x star y plus z is looking like xy star, meaning x multiplied by y plus z. As you can see, a simple left to right traverse will be enough to understand what the expression is and get evaluated. How to convert from infix to prefix or postfix. So stack can be helpful doing that. Infix as an expression or a type is easy for humans to evaluate. We saw that earlier, right? Following BODMAS rule of precedence. Operators are placed between operands. Traversal through expression goes back and forth. Prefix or postfix, we saw that earlier. No need for any precedence rule because the operand either has the operators before or before or after, and that's good enough to understand the expression and evaluate. During this conversion, a stack is used to keep track of operators present in the infix. Let's look at the algorithm for conversion of infix to postfix as an example. Create a string to store the converted expression. Right. After converting the infix to postfix, how do we access it or how do we know what is the outcome? So you need to have a string variable defined to store the convert expression. That's the first step. Input infix expression in a variable. So what is that I'm going to convert? That is already present in the infix format. For each character in the infix expression, if character is open brace, remember we followed the BODMAS rule of precedence in infix, right? So uh, that's what should be done. If there is an infix setup, we should look at braces first and the order, square, cube, and all those things next. Division, multiplication, addition, and subtraction, right? So if the character is open brace, push it in the stack. Else, if character is close braces, pop the elements from the stack and append to output string. What does it mean? See, uh, naturally, you're not going to read the close braces to start with, right? So you're going to have a variable, a character value, either an operand part or an operator part. If it is going to be in fixed, we know that operators are replaced between operands. So we are going to deal with either a brace or a part of set of operands, right? So if it is a brace, push it in stack. If an open brace, push it in stack. If it is closed brace, it means that we have come across an open brace, some operands, some operators, and we are coming to the point of closing that particular evaluation, the part of evaluation at least. So once it is there, which means you have part of the expression, a logical part of expression. So pop those elements that is there in the stack and put it in the output string. Since it's postfix, we are going to have the operator after that, right? So until the corresponding open braces, because that would be the first one, right? Typically, if you have open and closed braces, the open brace goes in first into stack. Remember, in stack, last in, first out. So the last character that we will be dealing with is close brace here. So until your open brace is reached, pop all the elements that were in the stack. So what will happen is you will have the close brace first, an operand, probably an operator, another operand, and open brace. In that order, you'll be having elements popped out. Now, discard the open and close braces and place those values in the output string. Else, if the character is an operator, you deal with either plus, minus, slash, star, double slash, whatever can be an operator. If it is an operator, then if its precedent is lower than that of the operator at the top of the stack, if its precedence, whatever we are coming across as an operator, if it is lower than that of the operator at the top of the stack, so multiplication takes precedence over your subtraction or addition, right? And if you happen to come across an operator within braces, naturally that is having a lower precedence than what is there in the top of the stack. If that is the case, pop elements from the stack till the operator with precedence less than the current operator is encountered. Else, push the operator onto the stack. Otherwise, if it is not an operator, then append the expression to the output string totally. Pop elements from the stack and append the output string till stack is empty. So you continue this operation until your stack becomes empty, and return the output string for further use. Now let's look at an illustration with an example. The expression as sample taken is x plus y divided by z multiplied by 8. So in the, I mean, we are going to use the stack with an implementation as a list in programming, but this is just illustration how uh, the operations happen using a stack. So initially the stack is empty, and there is a postfix string that we created to hold the final converted postfix expression called post exp. The stack is empty now. The first character, I mean, for each character in the string, in the input string, we want to traverse right, left to right. So first one is parenthesis, add it to the stack. At this point, the post exp string that is supposed to hold the final expression is still empty. And in the stack, we have open parenthesis. Now, the next character is x, or the next element in the stack is, or the input expression is x. So that is getting added to, since it is not open parenthesis, it's not an operator, we are appending that particular character to the post ESP string. So the stack has open parenthesis now, and the string has x. Now we come across an operator. So that is pushed into stack and stays there. The expression, I mean, the output expression string has x, the stack has an operator and open parenthesis. Now we come across y, it's another operand, so append that to the output string, and the output string has x, y, and we have open parenthesis and the operator sitting in the stack now. Now we come across the close parenthesis, meaning a logical operation or part of the expression is complete. So what the algorithm is supposed to do is pop elements from the stack, whatever is there in the stack, append to the expression excluding the parenthesis. So what really happens on the ground is we already have x and y sitting in the post exp string, and the stack had plus as an operator or a character element in the stack that is being added to the output string, discarding the open parenthesis and the close parenthesis that is become encountered. And the next symbol or next character in the input expression is slash, that is a divisor. So since it's an operator, push it into the stack. Now we are seeing an open parenthesis, push that also into the stack because it's not an operand, it's not an operator, just an open parenthesis which is supposed to go in. Now you come across another operand called z. So you add that to the post exp string. So now we have xy plus as the first part of expression, and z that we came across now. We come across star as an operator that is pushed into your stack, not to the output variable yet. Now we are seeing 8 as another operand that is getting added to your expression output string. So you have xy plus z8, and we are waiting for the next character, that is star. Now, sorry, 8. We completed till 8. Now we are coming across the close parenthesis. Remember, if you encounter close parenthesis, we are supposed to push whatever is present in the stack excluding parenthesis. When we pop out, remember we have our topmost element or the last entered element coming out. So your star comes out first, and then your divisor comes out last. So the final postfix expression is xy plus z8, I mean z multiplied by 8 and divided as a whole. So it gives a basic understanding. I mean, when it comes to implementation, there is a lot more to do it in terms of coding, but this is a basic understanding of how The conversion happens from infix to postfix. Basically, anything as an operand, keep adding to the output string, and as and when we encountered open and close parenthesis, pull out your operators, add it to the end of that particular part of expression. Now, evaluation of postfix expression. Say we have a postfix expression and how to get value, output value for that expression. So here is the algorithm. Input the postfix expression into a variable. For each character in the postfix expression, if character is an operand, character out of the stack. Else, pop two elements from the stack. If it is not an operand, you need to find the operands, right? Because in the postfix, remember we have operands first, an operator on those operands coming after them. So you're going to find two operands to operate with. So pop two elements from the stack and apply the operator on the popped elements and push the computer value onto the stack. So I have two operands taken out, and then what is an operator to be operated upon those operands? Push that onto the stack. If stack has a single element, then pop the element and output as the net result. Else output invalid expression. Let's have a quick recap of what stack is. Stack is a data structure in which insertion and deletion is done from one end only, which is referred to as a top. Stack follows last in first out. Push and pop are two basic operations performed on a stack for insertion and deletion of elements respectively. Trying to pop an element from an empty stack results in an underflow exception. And in Python, list is used for implementing a stack, and its built-in functions append and pop are used for insertion, deletion respectively. Any arithmetic expression can be represented in any of the three notations, namely infix, prefix, and postfix. Single traversal from left to right of a prefix of or postfix expression is sufficient to evaluate the expression as operators are placed as per the order of precedence. In a prefix, you'll have the operators placed before the operands. In a postfix expression, you'll have the operator placed after the operands. While conversion of an infix notation to its equivalent prefix or postfix notation, only operators are pushed onto stack. Remember, the operands don't go into the stack. Operands are placed onto the output variable that we define. Operators are just pushed in the stack. When evaluating any postfix expression, only operands are pushed in the stack. There is a difference, right? When you are creating or converting from infix to prefix or postfix, the operators are pushed or taken to the stack. On the contrary, while evaluating, the operands are pushed into the stack. Let's look at some programming samples that you can try out. First one, write a program to reverse a string using stack. This should be pretty straightforward. Evaluate the following postfix expressions while showing the status of stack after each operation. So the values given are a equal to 3, b equal to 5, c equal to 1, and d equal to 4. And these are the expressions you should try out. Convert the following infix notation to postfix notations, showing stack and string contents at each step. What we saw as a pictorial representation, write a program to show what is there in the stack, what is there in the output string in each step of the way. And of course, try out a few by yourself. There are so many programs that you can really try out using stack. Imagine a stack. We talked about some examples in the beginning, right? Say a bookshelf or a pile of chairs and so on. So you can pick one of them and write a program to implement a stack. See you in the next session. Thank you.